everybody, I am coming to you this morning from my office. I'm going to show you a couple things here this morning about what you're going to do today in science. So you're going to have your assignments going to look like this with one extra post up here that is going to be the video that I'm making right now. So hopefully you guys follow these directions. You guys are having a little bit of trouble of following all the directions, maybe not reading all the words that are on the page there. So hopefully you'll start reading all the words. But what you're going to do today is you're going to read the article about what meteorologists look for when they're tracking weather patterns. But first, you're going to watch this video, one that I'm making right now, read the article, and then you're going to answer the questions on the Google document that's titled Weather Trackers. So the first part is this article here. Weather trackers. I do apologize because the article is in 2 pages and the second page is actually some questions. Those questions you're not going to answer on that page. You're only going to read through page 1, not through page 1 and page 2. Make sure that you read all of it, including what's over here in this like pinky, purpley, brown area here. This is just some vocab and things like that. Then you're going to go to this page over here, which is the weather tracker document. On the weather tracker document, this is where you're going to answer all the questions. So these are the only questions that you're going to answer. So here you're going to answer these questions in a complete sentence. There's 5 of those. And then here you're just going to write true or false in the empty box. Okay, you can put a T or an F even. You want to. When you do that, then this is the only document that you guys should be turning in. Please don't turn in any of the other documents, the PDF and all that. It makes it easier for us to grade it if you just turn in this one document here. So it should look something like this. Again, it'll have one extra attachment here that will be the video. A couple things I want to talk to you about today really quickly before you do this is that, there's a lot of different tools and things that meteorologists use. We know that meteorologists are scientists who study weather. Meteorologists are on TV. I know sometimes they're not super accurate, but they do the best that they can. What some of those tools that they use are some of the things that you built last week, which is the barometer. And if you weren't able to build the barometer, then you need to just find a picture of one so you can see what one really looks like. So barometers do look a little different than the ones that we built here. But they use barometers. They measure that barometric pressure, which is that air pressure that's in the air, either high or low pressure. They use anemometers, which measure wind speed and direction. A lot of anemometers have a directional on there as well. We got a bunch of different, so in the atmosphere, we have different layers of the atmosphere. We have the troposphere, which is the 0 to 10 feet up above us, then the stratosphere, mesosphere, and thermosphere. So those are those different layers. So you're looking at those different things there. So the troposphere is where a lot of our weather comes to us from, the troposphere and the stratosphere. It's warmest down low and gets colder as you go up into those upper layers of the atmosphere. I had a really good question the other day from Lily Kohler. She asked me, why is it snowing in April? Well, it was snowing in April much for the same reason as we had, or actually you had. I didn't have much hail here. As for the same reason as there's hail. So if you watched Mr. Hames's video yesterday, I explained to you why there was hail, and hail's a little bit of a different exception there, but it's the same principle. It's super cold up there where those clouds are formed. They're formed pretty high up in the stratosphere, in the top of the mesosphere, and where those clouds are forming, it's really cold, like December cold. So that forms that precipitation that would be in those clouds into snow or ice crystals. And as they fall down, that makes snow. So that's what happens there. When hail happens, it's a little bit different. It does kind of bounce around in the clouds a little bit. So for every layer of hail, the bigger it is, the more it's bounced around in those clouds. Lily was very annoyed by the snow. I wasn't super happy with it, but I will tell you this, it's not the 4 feet of snow that my in-laws have right now in the Upper Peninsula of Michigan. So just so you know that. Mr. Hames also talked to you about the convection currents the other day. I'm going to do another video later this week about convection currents for you guys to watch. We're going to talk a little bit more about that and get a little bit more in depth. I know you guys have heard that term before, convection currents. We talked about that in our mantle. We do have convection currents there as well, but I want you to understand that there are also convection currents in the air. So I'm going to show it to you with water, but we're going to talk about how it works the same way in the air. Remember, Earth's rotation combined with different air temperatures, those convection currents that happen because of the 2 different air temperatures that are happening in a lot of areas. That's called the Coriolis effect, is making the air wind. Okay, that's what makes wind. And then that Coriolis effect is how they kind of curve in different directions. So we have that. I think that's going to be it for today, just to explain some of these things to you. If you have any questions, you guys can email me. Today's assignment is pretty straightforward. Hopefully you don't have too much trouble with it, but if you do, just go ahead and shoot me an email and I will be more than happy to get back to you.